Algorithm.
Odds are you've heard this word multiple times recently, felt a shiver of distrust, and made a mental note to learn more about it later. So, algorithms. That's what we'll be talking about today. What they are, where you can find them in our everyday lives, and what makes them so powerful. But before we get to algorithms, we need to spend a few moments talking about something most people find very frustrating: data. Computer science is all about information. The information computers store and send is called data. Data can be pictures, videos, text, numbers, and much, much more. Computers also use data to make decisions. Data comes from everywhere. Every time you click something online, like a post, buy something from a web store, or walk on the street, data is created. Data is stored in a database. Databases often represent the world using tables, which have rows and columns. Let's imagine a database for different kinds of candy. The more data you have, the more exciting things we can do. Maybe we want to get all the candy that is peach-colored, or all the candy that is white. Whether it's sound, music, movie ratings, probabilities, or code, computer sees it all as digits. That's what makes digital devices so useful. The same hardware can be used for multiple different purposes. In the past, we needed this to play music, and we needed this to show light, and even this to take photos. Nowadays, we only need this. All data in computers is represented as groups of zeros and ones. A single 0 or 1 is called a bit, and the number system that uses it is called the binary system. But 2 can be powerful. With only 2 bits, we can communicate 4 things. With 3 bits, we can do 8 things, and so forth. In reality, there are no candies or ones and zeros inside a computer. We could equally well say true or false, yes or no, pink or yellow. Really, it's tiny electrical switches that either pass electricity or don't pass. Computers may seem mysteriously active, weirdly alive, but they are mechanical devices like sewing machines. They just operate really, really fast. Next up, we are going to learn more about the kind of data we create by collecting some of the data big online services routinely gather about us.
The computer can remember videos that I searched in the past. The computer can remember my location.
Can a computer know your name?
Sometimes, yeah.
And this brings us to algorithms. Algorithms interact with data to solve computational problems. When an algorithm is done correctly, it can repeat the instructions over and over again. Like we talked before, algorithm is a well-defined process to solve a problem, like making cupcakes, finding the shortest route on a map, or adding puppy ears on your head in the right place. Algorithms seem like magic, but deep down they are fairly simple, and we need humans to write those algorithms. So an algorithm is just a step-by-step instruction to solving a problem, and the algorithm takes all the YouTube videos and puts them in the order. But an algorithm is a step-by-step instruction to solving a problem. And if I was an algorithm, how would I go about sorting these candies?
I know.
What kind of strategies could I have to put
I would have
these by color?
You should put the gummy worms first, and then the rings, and then who matches the colors like that.
Oh, that's a really good strategy. So you would first sort by shape. So you first put the gummy rings in one place?
Yeah, that's our like blue and pink or red, and then the another ones that are like, kind of different from them. But they are gummy worms, but they are another color. I should put them next.
As a group. I would start from the beginning and compare the 2 candies to one another. They look pretty okay. This one, on the other hand, looks bigger than the other one, so let's swap them around. These 2 look okay. And what about these 2? I think this one is bigger than the other. Let's swap them around. Again, let's swap. This looks okay. And here's the final one. Let's do this all over again. Do you remember what we learned while talking about programming? About sequence, selection, and iteration. The exact same thing happened here. First, we put instructions one after the other. Then we chose which part of the algorithm to execute based on a condition. And then finally, we repeated that part of the algorithm over and over again. Computer science is a science of very, very large and very, very small quantities. There are billions of likes, millions of pixels travel at the speed of light. But algorithms, they can also take billions of years to complete. A huge part of computer science is about understanding the efficiency of algorithms, how long they will take to run. Computers are fast, but they can get bogged down. Microseconds become years. There can be many different algorithms for solving the same problem, but some are more efficient than others. Some algorithms are more effective, work faster, require less memory. Some of them require information to be structured in a certain way, while others are very secure. Algorithms are everywhere around us, sorting, searching, recommending, and rating. Sometimes it's hard to notice an algorithm at work. On video sharing platforms, algorithms choose the ads and recommend videos for you. The most popular video sharing platforms see over 400 hours of new content uploaded every minute. This means there is no way for a human to go through everything. And that's where the algorithms come to play. The algorithm takes into account at least your past viewing history, the likes, watch-through rates, comments, and tags to make recommendations to you. But the algorithms are also influencing the kind of videos and content we make. And that's the scary side of algorithms. Where could there be a YouTube algorithm when you watch YouTube?
A video.
Video, yeah. The kind of videos that get recommended for you, those are defined by an algorithm.
Music videos.
Have you ever seen ads on YouTube?
Yes, many times.
What kind of ads do you see on YouTube?
Like download the game.
Download the game ads? What about you? What kind of ads have you seen on YouTube?
Download the game ads.
Yeah. There are many great algorithms in the world. Algorithms have names like Knuth Morris Pratt, Diffie-Hellman key exchange, or hidden Markov model. They are wonderful, curious, imaginative little poems that help us classify characters as vowels or consonants, diagnose heart failure, or compress files. While different programming languages write the algorithm out in different ways, the underlying logic is still the same. The audience for an algorithm is always a human being, not a computer.
Dear Linda, how do computers work?